Now, when you go to the grocery store, they price things different ways. Okay? Because you measure things in different ways. When you go up to the meat counter, you go to buy something, you buy it by the pound, right? Or in Europe, you buy it by the kilogram. So we can measure mass. We buy soda. We measure volume, right? 2 liters, gallon of milk. Okay. But there's one more way they price things at the grocery store. You don't buy eggs by mass or by volume. You buy them each, right? Okay. You can count the pieces. So we're going to need a count the pieces. We can measure mass in grams. We measure volume in liters. And we need a number like dozen. Okay? Or words that mean a number. Dozen means 12. Score means 20. 7 years ago. Gross means a dozen, 144. Okay? So we need a word that a metric word, but those numbers I've picked are too small a group for atoms because atoms are tiny. There's not going to be a whole lot of difference to you between a dozen atoms and one atom, or even 144 atoms and one atom. Okay, so they've come up with a new unit. It is called the mole. And it's a unit that's used primarily in chemistry. You have probably not seen this unit anyplace before unless they gave you a list of them and you wrote it down. In fact, that's what we did with it. I gave you a list of it, you wrote it down, and we moved on. Okay? Because you don't need it until you start talking about counting atoms. Okay? So they had to pick a number. Okay? It had to be a pretty big number because atoms are tiny. So what they picked was the number of carbon atoms in exactly 12 grams of carbon-12. We've talked about them defining two different things, the AMU and the mole. It's not accidental, they're both based on carbon-12. They did that on purpose, and we'll see why in just a second. Okay, so 12 grams of carbon-12. 12 grams of carbon-12. 12 grams of carbon is about the weight of the lead inside a wooden pencil. About 12 grams. Okay, so I'm going to start writing the number. You tell me. Stop. Tell me when you stop and when you think that I've written enough zeros. Okay, I'm going to start with the 0 end and work my way to the number. Well, there's billion. Do you think there'd be a billion atoms in 12 grams? More? More? Trillion? Quadrillion? Is that it? That's pretty big. That's pretty big, isn't it? Okay, so some people said stop here. 1, 2, 3, 4, 5, 6, 7. Yeah, it works out to be here. 6.022 times 10 to the 23rd. So this is the 2. Now, it's only 4 sig figs because that's usually what the limit of it. When you read in the book, you saw they know it to 7 sig figs. So they know it to more than this, but this way when we use it, if we use 6.022 times 10 to the 23rd, we won't limit sig figs from doing math. Because we wouldn't want to use something that everybody knows and limit our sig figs because we didn't bother to copy enough numbers down. That'd be kind of silly. That'd be kind of lazy. Okay, so, but it's just a number. If you had a dozen donuts, you'd have 12 donuts. If you had a gross of donuts, you'd have 144 donuts. If you had a mole of donuts, you would have 6.022 times 10 to the 23rd donuts. Okay, it's hard to get a sense for how big this is. So I'm going to actually do some conversion factors, okay? Just to give you a sense of, okay? And where it comes to mind is that I was going to buy a mole of stuff, okay? So I thought I'd get something small like BBs. And BBs, I'm actually going to make them smaller than they are. Let's say a BB is 1 millimeter in diameter, right? How big a cube would BBs make, would a mole of BBs make? Okay. Well, if I had a mole of BBs, I'd have 6.022 times 10 to the 23rd BBs, right? And each BB is 1 millimeter. So I'd have, it's probably not the right place to do that because that would just tell me how long a line it would be. I don't want a line, I want a cube, right? So I need to figure out how many would be on each side. I need to take the cube root of this number. So the cube root of that. So 6.022 to the power of 1 divided by 3, because I can't find the cube root button. And so that equals 1, 2, 3, 4, 5, 6. It's about 84 million BBs, which means 84 million millimeters on each side. 84 million millimeters. These millimeters to meters, divide by 1,000. And then meters to yards, 1.094 yards. And then yards to miles. 1 mile is 1,760. So if I divide that by 1,000 times 1.094 divided by 1760, and I get 52 miles. So if I wanted to buy a mole of BBs, I'd have to buy a box that was from here to Los Angeles long, because it's 50 miles to LA. Here to Los Angeles tall, and here to Los Angeles wide. And that would be 1 mole of BBs. That's 1 mole of BBs. That's that many. That's how big a box you would need to carry that many BBs. That tells us 2 things. 1, the mole is an unbelievably big number, because you didn't picture 50 miles on a side. Okay. 2, if you have that many atoms of carbon, it's this big. So if a BB is a millimeter, how small is an atom? So the mole's a huge number, and atoms are unbelievably tiny. Okay? Hopefully that emphasizes that point. Okay. But it's called Avogadro's number. after a scientist whose name is Avogadro. He didn't come up with a number, but he was the one who said it's important to talk about how many you have. He's the one who said the number was the important part. So 1 mole is 6.022 times 10 to the 23rd particles. 1 mole is Avogadro's number of particles. So here's how you can remember. This is one way you can remember it. There's an avocado's number of moles, avocado numbers of pieces in a guacamole. Okay. Hey, look at what we just wrote. We wrote that two things are equal to each other. We can make conversion factors out of those. So, how many atoms of carbon are there in 4.56 moles of carbon? More than one. Well, yeah, more than one. No new math, just new equal stuff. .56 moles of carbon. Yep, it still sucks. What unit do you want to get rid of? Moles of carbon, where's it got to go? On the bottom, what can I turn moles of carbon into? Do I know, what kind of parts make up carbon? Carbon is an element, so it's made up of atoms, right? So I can go from moles to atoms of carbon, because 1 mole is 6.022 times 10 to the 23rd atoms. A big number. Avogadro's number. So 4.56 times 6.022 times 10 to the 23rd gets me 2.75, 3 sig figs in the 4.56, 4 in the 6.022, times 10 to the 24th atoms of carbon. Extra super tough? Any guesses what the next question is going to be? Yeah, put atoms into moles, right? If it works one way, it works the other way too. If I can turn atoms into moles, if I can turn moles into atoms, I can turn atoms into moles. See, beauty here, I did not have to teach you any new math. I just had to teach you new equals. What unit do I want to get rid of? Atoms of Fe. Where's it got to go? On the bottom. You can turn that into moles of Fe, because 1 mole is Avogadro's number of atoms. So 5.87 EE22 divided by 6.022 EE23 equals 0.0975. The 0 in front doesn't count. 3 sig figs in the 5.87, 4 in the 6.022. And that is moles of Fe. I have less than 1 mole because 10 to the 22nd is less than 10 to the 23rd. Just look at the exponents in the numbers. It looks like it should be about 1/10, right? At about 1/10 of the mole. Extra super hard. So now all we have to do is find a way to count to 5.87 times 10 to the 22nd. Is that an option? No, not have time. The period's only 56 minutes. And you need 100 lifetimes of the universe to do it. Okay. So what can we measure that will tell us moles? Well, we said that the mole was the number of atoms in 12 grams of carbon-12, right? So there's got to be a connection between grams and atoms. Okay? And we talked about carbon-12 on the bell work today, didn't you? So you said the AMU was 1/12 the mass of a carbon-12 atom. Isn't that what you said? And just a few minutes ago, we wrote that the mole is the number of atoms in 12 grams of carbon-12. It wasn't accidental that they based them both on carbon-12. Because look at a different way of writing this. The first one, 12 AMU equals 1 atom of carbon-12. Remember, see how that's what that first sentence says? That if the AMU is 1/12 the mass of a carbon-12 atom, then 12 AMUs would be how heavy one carbon-12 atom was. And 12 grams equals 1 mole carbon-12. Everybody see this ratio? That if it's in AMUs, I'm talking about atoms, and if it's in grams, I'm talking about moles. So on the bell work today, the second question I asked you, or the first question I asked you is, what is the decimal number on the periodic table? What was it? Not just atomic mass, average atomic mass, right? Okay. But because 12 AMUs is 1 atom and 12 grams is 1 mole, it's also the mass of 1 mole of those atoms. That same number is 2 different things. It's how heavy the average atom is in AMUs, and it's how heavy a mole of those atoms would be in grams. Okay. So that is called the atomic mass in a different way. The mass of 1 mole of an element in grams. So if I look on the periodic table and I look up carbon, it says 12.01. Hydrogen, it says 1.01. Iron, it says 55.85. I just looked up the numbers on the periodic table for each of these. What do those numbers mean? Well, it means that 12.01 grams of carbon has the same number of atoms as 1.01 grams of hydrogen, which is the same number of atoms as 5.85 grams of iron, because they're all 1 mole. And 1 mole is 6.022 times 10 to the 23rd atoms. So all of these, even though they weigh different, they all equal 1 mole. Oh, and that's the official abbreviation for mole. You leave off the E. The shortest word has the longest abbreviation. So I have a number, the mole, on one part, and I've got weight on the other. I could write 12.01 grams of carbon equals 1 mole. I could write 1.01 grams of hydrogen equals 1 mole. I could write 55.85 grams of iron equals 1 mole. I just take the number off the periodic table, and that's what the average atom weighs in AMUs, but when I'm counting them, it's how many grams for 1 mole. So the same number means two different things. And you'll know which one they're doing by what unit they stick after it. If they stick grams after it, they're talking about moles. If they stick atomic mass units, they're talking about atoms. Because the atomic mass unit is probably a clue that you're talking about individual atoms. So, grams on one side, a mass. Moles on the other side, a number. What can I make out of that? Conversion factors that will let me count things by weighing them. Because I do not want to count up to those kinds of numbers. I'd rather stick it on a balance and do a conversion factor. As much as you complain about it, it's a lot shorter than the other option. Get out a force electron microscope and move one atom at a time. Oh, they have machines that can do that. Okay, so how much would 2.34 moles of carbon weigh? What unit do I want to get rid of? Moles of carbon, where's it got to go? On the bottom. What can I turn moles of carbon into? Grams of carbon. And the number for moles and grams I get off the periodic table. Next to carbon it says 12.01. That's the grams because the periodic table tells me how much 1 mole weighs. So 2.34 times 12.01 equals 28.1. Because the 2.34 has 3 sig figs. The 12.01 has 4. So 3 in my answer. And that's grams of carbon because the moles of carbon canceled out. Pretty easy, pretty straightforward.
It's confusing, but
It's just math. No, and the math is easy. As long as you let the units tell you how to do it. If you try to remember whether you're supposed to multiply or divide, you'll make a mistake 1/4 of the time. But if you just put the units in the right place, you only make the mistake 1/20th of the time. Because we still write the wrong numbers in the places that, right? We copy badly. It happens. Okay, so how many moles of magnesium is 4.61 grams of magnesium? So they gave me 4.61 grams. That's what I want to change. I want to get rid of grams of magnesium, so it goes on the bottom. I want moles of magnesium. Goes on top. 1 mole is 24.31 grams. You got that off the periodic table. So 4.61 divided by 24.31 equals 0.190. Yeah, that 6 rounds up to 9. Still need to keep the 0 for sig fig. And that's moles of magnesium. So I started off with how heavy it was, and I ended up with a number. But it's not, that doesn't look like a number, does it? But it is just a number, just like a dozen is a number. But If I wanted to know the exact number of atoms, could I figure it out? Because I can turn moles into atoms. So, how many atoms in a gram of lithium? So I want to get rid of grams of lithium. Grams of lithium I can turn into moles of lithium. Because I got a periodic table and it says 1 mole is 6.94 grams. But that's not the unit I want. I want to get rid of moles on the bottom, and I want atoms of lithium. And 1 mole is Avogadro's number of atoms. So 1 divided by 6.94 times 6.022 EE23 equals 8.68 times 10 to the 22nd atoms of lithium. Does everybody see why we learned this stuff in the first unit?
Are you sure? 8.67.
I got 8.677 behind it, so that's why I rounded up.
8.674.
6.94, you probably left off the second 2.
I did significant figures for the first.
Oh, no. This is all multiplication. You only went around once. We haven't changed rules. Okay? Does that make sense?
Yeah.
We don't want to round. If we keep rounding, we're going to get further and further off occasionally. Okay? So we want to round as few times as possible. We have to stop and round when we subtract before we can multiply, or we multiply before we can add. But as long as we're just doing multiplication, we just keep the numbers in our calculator and just keep going. Push them one right after the other. Okay, usually about this time, somebody raised their hand, says, ooh, Mr. Green, do I have to write lithium? And the answer is yes, because eventually we're going to get conversion factors that's what changes. We'll start off talking about lithium and end up talking about a different chemical. So this time the mole changed. Eventually it's the lithium that's going to change. So that's why you want to get in the habit of writing it, because that's the part we're going to change later. Okay? Hopefully you see, I got a plan for all this. Okay. So, how much would 3.45 times 10 to the 22nd atoms of uranium weigh? Well, I want to get rid of atoms of uranium. And atoms of uranium I can turn into moles of uranium. Because 1 mole of anything is 6.022 times 10 to the 23 pieces. And the pieces this time are atoms. Now there won't always be compounds out there, but we'll deal with compounds later. What we do when it's compounds. Cancel that. Now, uranium, and I want to turn that into grams of uranium. And the moles is 1, because I know 1 mole of uranium weighs 238.03 grams. So 3.45 EE22 divided by 6.022 EE23 times 2, 38.03 gets me 13.6 grams of uranium. So, how much would an atom of gold weigh? I'll answer it the easy way, you answer it the hard way. The easy way. There, that's the easy way. Isn't that what one atom of gold would weigh? The number off the periodic table. It would weigh 196.97 AMUs. But we don't have a balance that measures in AMUs. So we probably want it in grams. Okay? So I start off with one atom of gold. I want to get rid of atoms of gold. What can I turn atoms of gold into? I can turn it into moles of gold. Because 1 mole is 6.022 times 10 to the 23rd atoms. And now I can get rid of moles of gold, change it into grams of gold. 1 mole is 196.97 grams. Since I already looked up the AMUs, I knew what it was in grams too. And after everything cancels out, pushing buttons, 1 divided by 6.022 E23 times 196.97 equals 3.0 sig figs. How many sig figs should I have? Okay, the one atom. How many sig figs in one atom? Unlimited. I can't. Yeah. I can't have 1.1 atoms, right? So we're counting here, right? So the one's unlimited. The Avogadro's number has 4. The mass has 5. I get to have 4 in my answer. So 3.271 times 10 to the negative 22nd grams of gold. And now do you see why we invented the AMU? Because this is what the average gold atom weighs. So all you have to do is do math with that every time you want to talk about how heavy something made out of gold is. Yeah. Because you're divided by 10 to the 23rd. That means your your exponent is minus whatever 10 to the minus 23. Yeah, so you subtract 23 from anything, you're going to get a really small number. Okay? So we have ways of counting by weighing. Okay? So, hey, those look familiar. That looks like 5, 6, and 7. Got 5 minutes. Practice a few so when you get home tonight, the other ones will go faster. You have something to go back and look at.